Hi, how's it going? We're back here with another AP Physics 2 video. This is on electric field, force, and electric potential. And if you were with me in the last video, you saw how we went through all of the um, electricity equations and really showed how they're interconnected and how we can use them in different situations. So the way I ended that last video, um, I talked about, I pull this over here, the electric field can be written with units of volts per meter, but it can also be written in units of newtons per coulomb. And where does that come from? That comes directly from the two electric field equations that are on our reference table. Force over charge, so that's newtons per coulomb, and potential, electric potential over a distance, so this is volts per meter. And I just wanted to do a little quick unit analysis to understand how could that be possible. These look super different to me, and they actually conceptually have different meaning in my mind, right? To me, if I'm moving within these parallel plates from here to here, I could say, all right, every meter I move, I must be gaining some number of volts. And here, I'm thinking, okay, if I put a charge in here, let's put a charge at this location, which has an electric field strength of E, well, that means that depending on the coulombs, the number of coulombs that I place here, then I'll know how much force this thing feels. So conceptually, it means two different things, but actually, um, they are equivalent. So let's look at a little bit at this. So volts. What is a volt? So whenever I'm asking these types of questions for myself, I try and look at, all right, where do these equations get, um, what equation tells me about volts? Which one do I know that tells me about volts? Maybe when I think of volts, I think of ah, when I think of volts, I think of, well, a volt, well, maybe I'll go a step back. I think of this equation, okay? So um, delta, change in our electric potential energy is V times Q. So actually, I don't go, my brain goes straight to this. I think of electric potential as how much electric potential energy is there per unit charge. That's where I go right away. Okay. And then I think about, all right, so now I know a volt is not just its own unit, it's made up of base units. It's made up of, well, potential energy is joules, and joules over Q, Q is charge. Okay. So now I'm seeing, all right, I'm getting closer to this charge here. Now, what is a joule? What is a joule? Well, a joule is just when and again, I do a similar thing. I think of equations that help me think of what these units are. So a joule is a unit of energy. What equation I think of for energy is work is force times distance. So now I know joules are equal to newtons times meters. All right, so let's take that and plug it in for joules. So a volt is really a newton meter per coulomb. All right. So when I take this and I plug it in, right, that's what a volt is. A volt is a newton meter per coulomb, and I plug it in here. Well, now I see that newton meters per coulomb divided by meters. Well, what happens here? My meters drop out, and I'm left with newtons per coulomb, which is exactly what I said the other units are for electric field. So what do I expect you? Well, hopefully you walk away with this and you say, all right, from these two equations, sorry, this top one here and this one down here, from those equations, I know that there are two kind of standard sets of units that can be used for electric field. I hope you got that. And then I hope you realize, well, if they're both representing electric field, they have to be equal to each other. And now we have a proof of why they're equal. And whenever you're trying to figure out, what units make up another unit, we find an equation. In this case, our voltage is equal to our change in potential energy, electric potential energy divided by its charge. And we can say, all right, we know the units of these things. And the same thing, I did the same thing for joules, right? I said, all right, well, what's joules? Well, I know work is joules, which is newtons times meters. So a little bit of dimensional analysis, looking at some units, but hopefully gives you a little bit of a better understanding that electric field can be both how much your potential energy changes per distance you go, or it could be if you put a charge in there with some amount of charge, how much force will it feel? Hope it helps. Take care. Next video, we're going to actually take a look at an AP question and start looking at what do isolines of electric potential mean. So hopefully I see you on that next video. Take care.